here it says, we can use matrices to solve the simultaneous equations by using inverse matrices and following the form for simultaneous equations, this. Okay, so let's just look at this and then we're really going to break it down. So here we've got ax plus by is equal to m and cx plus dy is equal to n. So we've got a pair of simultaneous equations. We then, as you can see here, wrote them as matrices. So by going A, B, C, D and putting them all in a matrix, then we've taken, if I come here, we've taken our two unknowns, x and y, and we'll put them in a matrix, and then we'll put our answers also in a matrix. So m and n we'll put into a matrix. So therefore, what we can say is a times x is equal to c. This is what we've seen lots of times before. We've taken our simultaneous equations, we'll put them into matrices. So that's what we've seen previously. Now what we want to do is figure out what x is. So in order to figure out what x is, we need to get rid of this a. And in order to do that, we're going to use our knowledge of inverse matrices. And this is what our final answer is going to be. So we're going to talk through now how exactly this works. So let's go through this. We use matrices to solve the simultaneous equations to find x and y. So that's what we're trying to do. We're trying to solve for x and y here. Write the equations as a matrix equation. So take your simultaneous equations and write them as matrices, which we've seen previously. Step 2. To solve the equation, we must undo it. To get xy on its own, we use the inverse of matrix A. So what we want to do is we want to get xy by itself. So what we have to do is use the inverse of matrix A. So here's A. Remember, to find the inverse of something, you first find the determinant, and then with that determinant, you can then find the inverse. So here it is. And now, this is what you're going to do. And I'm actually going to write this out before we come here. So can I get you to write this out for me as well? So what we've got is we've got A times x is equal to c. And what we want is to get x by itself. Well, to do that, what you do is you multiply this side by the inverse of a, and whatever you do to one side, you must do to the other. So we're going to multiply that by the inverse of a. The order here is important. It has to be in front of c. And then what can we say next? Well, we know that the inverse of a multiplied by a is just equal to the identity matrix. So this is going to be the identity matrix times by x is equal to a negative 1c. So a, the inverse of a is c. The identity matrix times x is just x. Because remember, the identity matrix functions as the number 1. It's just like multiplying something by 1. So as you can see, x is going to be the inverse of a multiplied by c. And that right there is our answer. Because as you can see, we've got an x by itself. X will be equal to this. And that's exactly what step 3 tells us to do, to multiply matrix C by the inverse of A. And that is the working out that we've just seen here. So as you can see, we've taken, and I should really get the colors a bit more coordinated here. I've taken this inverse and I've put it here. And as you can see, I'm also multiplying it by C. And that's giving me what the x and y is there. A very important note here, note, order is important here. It must always be the inverse of A multiplied by C. And then of course your final answer here, if you know that this matrix is equal to this, well, x is equal to 5 and y is equal to negative 2. X is equal to 5 and y is equal to negative 2. That's how it works. Hopefully that makes sense on how it is I've approached this. And we're now going to go through a bunch of examples where we see this in action.